Yeah, they should be ready. They get ahead of time. And without any further ado, the man who needs to stop playing with DNS, Dan Kaminsky. Give him a huge round of applause. Thank you.
Hey guys. Dear God, this was one hell of a year. Hey everyone, it's great to be here. This is, I think, my 5th CCC. Every year I always have such a warm and excellent time here. It's just an honor to be asked to come out to speak. So, how many of you guys have seen video or slides of the talk I gave at Black Hat? Yeah, that's not this talk. If you haven't seen that talk, hopefully you won't be too confused. But I was actually talking to the CCC guys, and they really wanted to hear, there's been a fairly ridiculous amount of press on all of this. They really wanted to hear less about what the actual bug was, and more about, so what the heck have you just spent the last year doing? Because we all know it didn't take that long to find the bug in the first place, and that's actually true. So this talk is much more about the larger scale lessons to be learned from the experience of attempting to repair a critical piece of critical infrastructure. So what are we here to do? We're here to do 4 things. We are going to quickly recap what the flaw was and the scope of things that it affected. We're going to analyze what forces allowed. This shouldn't have mattered. DNS shouldn't have been this significant. And yet, as I explored all of the various things that were using DNS, it just struck me. This is ridiculous. Why are this many security-sensitive decisions being made on something that has never taken a security dependency in its design? We'll talk about how this issue actually got fixed and some of the tales of those 6 months. I think the quote from Paul Vixie was, "I just spent 6 months trapped in a well with Dan Kaminsky, and, well, it's nice to be free now." And the 4th thing we're going to talk about is DNSSEC, which is, believe it or not, might actually not be a bad idea. So, let's talk about the flaw. The flaw indeed originates with Dan J. Bernstein, who pointed out in 1999 that the 16-bit transaction ID in DNS, yeah, that's probably not enough. Okay, DJB was totally right. And the response he got back, what eventually the DNS community convinced themselves of, was that, yeah, 1 out of 65,000 isn't very long odds. But maybe we can make it so you can only play those odds like once an hour, once a day. And like 32,000 days is a really long time, so maybe we don't need to completely top to bottom, re-engineer the protocol or do any kind of these crazy fixes that are going to make things slow. You know what? It was 1999. People were a little naive back then. And yet, if you actually look all the way forward through 2008, this TTL strategy was about 1 draft away from becoming a RFC called forgery resilience. People really believed this TTL stuff was enough to stop DJB. They were wrong. They were totally wrong. People talk about the Kaminsky attack as if there was one attack. Yeah, there's like 15 different reasons why that entire philosophy was wrong. There's just so many different ways to, instead of only being able to run the attack once a day, so you have to wait like, 83 years. Yeah, you can run the attack a couple thousand times a second, so you have to wait, 5 or 6 seconds. It's not like 1 or 2 ways. It's really a lot. The only other thing I maybe figured out was that because the attacker controls when the query happens, since you start the race, you can actually get more than 1 reply in pretty reliably. In fact, you can get more than 100 replies in pretty reliably. So the entire philosophy of the system was just broken from the start. So what should have happened? What should have happened when the bug was found is nothing. No important system should have been vulnerable. As Halvar Flake actually said, "I fail to understand the seriousness with which this bug is handled, though. Anybody who uses the internet has to assume that his gateway is owned." I wish the world was as smart as Halvar. It would make things a lot easier. Unfortunately, it's not the case. Not to repeat all the slides, but secure systems are depressingly rare in the field. Most things don't even bother to be secure. The vast majority of the web is over HTTP. Email, which has the highest sensitive information to total lack of cryptography ratio of anything in information technology. And oh, by the way, you know, there's more to networking than web browsers. There's like these other applications that also use sockets. And they all suck. Of course, you know, not to, you know, let's talk about SSL. Most of those things that try to use SSL, yeah, they fail pretty miserably. When you actually scan the internet, you find about 41% of SSL certificates out there. They're self-signed. They're not even trying. Their client's like, who are you encrypting to? I don't know. Non-browser network applications that use SSL just don't care if the cert signed by anyone in particular. They're encrypting to someone, I don't know who. There are some pretty scary implications of this. Automatic updaters are non-browser network applications that assume DNS is safe. They assume quite incorrectly. There's a fantastic video put out by Francisco Amato with his tool EvilGrade. It just demonstrates owning the Java updater. SSL itself used email to authenticate its receivers to determine whether, I don't know, I should be able to get a cert for verisign.com. And forgot my password systems, bypassed authentication entirely. Now, I don't think people have fully grasped how significant an authentication bypass through forgot my password is. So I thought I'd step through a little demo. And if you've been watching my Twitter stream, this is what I've been spending all day trying to get to work just right. So we're going to go ahead and spin up a little bit of a victim Drupal site. This is frontend.doxpera.com. You know, it's my little collection of Fresh Prince of Bel-Air lyrics. And we're going to create an account on it. And we're going to force an email to be sent to a test domain, this helloccc.docsdns1.com. Now that's going to cause the mail server that backs up my web server to go ahead and send an email. That's going to cause the DNS server that backs up my mail server to figure out where that email is supposed to go. That's going to cause me to see who the name server is and what ports it's using. So now I go to my test server and I see, oh, okay, well the IP address is 209.40.204.174. Would be a shame if someone were to poison that name server. Now we need to have a name server that says, if anyone were to happen to come to me, clearly they want to send me their traffic and their email. Now we go ahead and just, use Metasploit. Let's go ahead and grab all of doxpera.com as per this particular name server and redirect it to our attack box. Now we forget the password of the admin. Well, what's his name? His name is apparently Little Bobby Tables. What's his password? I don't know. I'm just going to say I forgot. And it's going to send me an email. And you know what's going to be in there? Little Bobby Tables. A request to reset the password for your account has been made at Drupal. Please click this link. Hey, it wanted to know where to send it. It asked DNS, who is the mail server for this particular administrator? Said, no, yeah, that would be me. Sweet. So I go ahead, I enter the administrative interface, and it's like, this is a one-time login. It's going to expire. Click this button to log into the site and change your password. Apparently this can only be used once. Yeah, so we're going to go ahead and post some content on this page. And I don't know if you can see it up there, but I'd like to highlight post content input format PHP code. Yeah. Title, you got pwned. System, you name A. That's right. Why the hell did that work? No, I'm serious. I mean, why? Passwords. We can forget our passwords and have them mailed to us. Admins have passwords too. Admins forget. Admins have code execution rights on pretty much every content management system out there. I'm not just picking on Drupal here. This would hit Drupal, would hit WordPress, would probably hit Joomla, and pretty much anything else you can find out there. One generic category of attack, and that thing's going to get code execution all over the place. Now, just to be fair to Drupal, they're totally on top of this. They're building a detection interface. They're pretty interested in all of this stuff. But really, is this Drupal's fault? If there was a code execution flaw in the Linux TCP stack, would it be Drupal's responsibility to say, wait, you're running on Linux 2.6.189.3. This TCP stack is vulnerable? No, because it's not a bug in Drupal. It's not a bug in the web server. It's not a bug in the mail server. You got to go all the way down into the name server. But that one bug traverses all the way back. So now we just received a code execution equivalent token over email. So that's the seriousness of which this bug is handled. Why did this work? Why did this happen? Clearly, this is the fault of passwords. No, really. I mean, without passwords, there would have been nothing to forget. With nothing to forget, there would have been no reminder email. Without email, there would have been no dependency on DNS. And without DNS, there would have been no exposure to cache poisoning. So clearly, we need to stop using passwords and only use SSL client certificates. Who the hell here wants to use SSL client certificates? That's right. They suck. Okay, if you don't understand the problem, you're not going to find the solution. We have some bad habits in the security industry. Sometimes we'll make an appeal to morality. Well, if you were a good programmer, you'd use SSL client certificates instead of passwords. You could make an appeal to intelligence. Well, if you were a smart programmer, if you just knew how to write your code well, as opposed to all these monkey coders, you'd use SSL client certificates instead of passwords. Now, this approach is emotionally great for us as security engineers because it makes us the good guys and it makes us the smart guys. Yeah, you know what? I've spent a lot of time around people who build complicated systems. Takes them 2 years to build it. Takes us 2 weeks to break it. That means we have the easy job. Look, neither argument on morality or intelligence is compelling at all. SSL client certificates are awkward and expensive to manage and fundamentally fail a ton of critical use case scenarios. Passwords scale, and that matters. If you have a system that scales, people will use it, they will deploy it, they will build their businesses on it, whether or not it meets any sort of security purist approach. That's just the reality of things. And the number of hands that came up with people saying, I would love to use SSL client certs, is the reason why. Now here's the deal. It's not just passwords that scale. DNS does as well, like nothing else. Who here is familiar with the concept of federation? So, definition of federation, the formation of a political unity with the central government by a number of separate states, each of which retains control over its own internal affairs. Put another way, Microsoft does not trust Google. Google does not trust Yahoo. Yahoo does not trust CNN. But all three of them share a single namespace, the DNS, and all control completely operations within their particular namespace. This is hard. This is really hard. First off, it requires technology. The synchronization of distributed database is a classically difficult problem, but it's more than just a technological problem. It requires groups that are set up to absorb new information and new records and new delegations. It requires human factors. It requires registries and registrars. It requires an IT guy in your organization that you can talk to say, hey, I got a new box, it's at this IP. Stick it in the namespace here. And that needs to work. And it does. Because DNS came first. Because DNS has been around since 1983. How many of you weren't around in 1983? I just happen to be curious. You know? Seriously, like, this thing has been around for the entire history of the modern internet, and even long before that. The first mover advantage has made it the source, the only source of successful federation.